What? Okay, so let me wait for a few minutes and we'll start. What else? We have how many? Okay, we have 9 of them. So, okay. I'm not going to upload this, so please. Okay, so we'll start with the math. We'll start with the math, linear algebra part. Okay, I want to. Let me see how many of them are there. We have 9 of them. Some of them I have already uploaded as a practice problem, math part. I'll work on it. I'll do the same problems. So I'm pretty sure you have seen the exam 3 guide, right?
Yes.
Yeah, I've seen
Okay.
it.
So exam 3 guide, we have the first one is we start with the math part. So we will start with linear equation. So you'll be given a linear equation and you can solve it using uh, either a row reduction method or maybe a Kramers rule. It's up to you. I think I did both in the class. So let me see my example I was going to go through. I think I have it over here. It is out of what? I think I uploaded. I put it over here. Yeah, this is what I have. Okay, so you'll have 4 questions and 25 point each. So you'll have enough time for notes. Don't put the examples directly from the practice problem or from the class problem. Um, uh, so let me start. So let me share my screen first. So first one is a linear equation using solve the linear equation using one of the methods studied in class. So that is you have to solve the linear equation. We have done it in I think 2 different ways: Kramers rule and reduced row reduction method. So whichever is you find easier, you can do that. Okay. So let's start with let me write 3. Oh, let me write 1. Why write 3? Okay. So first problem. So exam review. Can you guys see my screen?
Yep.
Yeah.
Yes.
Exam review. All right. So our system of equations. So like your questions will be similar to this. It may be exactly this, but it is the same thing. So provided the following system of equations. Suppose the equation is like 3x1 minus 6x2 plus 9x3 equals to 1, right? Minus 2x1 plus 7x2 minus 2x3 equals to 2, and x2 plus 5x3 equals to 3. So I may also ask to describe this in matrix form. So we have done this in class too. I may not have specified the matrix form, but I've shown you how to do it. So it is ax b, right? So, or you can also put it in augmented form, but 3 minus 6 9 minus 2 7 minus 2 0 1 5, right? This is your x2, that's the x vector, and your b is 1 2 3, right? Yes. So in this case, your a is what? I don't want to write this. You can just do this. Just do. This is your a. This is your x, and this is your b. And you can, if you want to do with row reduction form, we can do the augmented form and do it. Or if you want to do it the Kramers rule, it's up to you. So today I'll solve with Kramers rule. You can solve it either way. It's okay with me because my note has the Kramers rule. Sounds good.
Professor?
Yeah.
In the second column there at the x's, the bottom one should be x3, right?
Yes. So you are good. Sounds good, guys. Yes.
Yeah.
Yeah. Okay. So second question may be B, maybe using one of the method is shown in class, solve using one of the method shown in class, solve x1 x2 and x3. Okay, this can be or yeah, it will be similar to this if it is there in the exam. Okay, so if I use the Kramers rule, I need to find the determinant of A, right? So how do we find determinant of A? We know that 3, and when you do this, you cross out this and you use this sub matrix. So 3 7 2 1 5.
-2.
Likewise, if you want to do
-2, I think.
yeah, -2. And if I want to do the second, I'll take this column and this column, this row will be out, and this is my sub matrix. So it is -6, -6.
So -6 would be +6, yeah, and then -2, 7, 0, 1.
Yes, thank you. So similarly, it will be +9. That this column and this row, it will be -2, 7, 0, 1. 0, 1.
Oh, you put -2 twice, I think. Isn't it supposed
No,
to
that's
be
right. That's right.
-2, 7?
No, because he crossed out the middle row.
Oh, wait, I see. Yeah, never mind. Okay, yeah.
Yeah, sure. Yeah, thank you guys. Okay, so now we can solve this, right? I want to solve this. Solve with me. This should be a very good practice for you guys too. So 35 minus +2 +6 -10 -10 -0 +0, it doesn't matter, so it's -10 +9 -2. Because 0 multiply, this should be 0. 0 multiply, this should be 0. So it doesn't really have to do that. So 37 times 3, 37, 3 times 37. This is plus and -60 -18. So 111 -78. So 33. So we can do this. Determinant is not equal to 0. So in Kramers rule, what we do is we replace the A matrix with the B term. So we do it one by one, right? So when I say A1, I replace the first column with the B. Our B is 1, 2, 3. So 1, 2, 3, and others remain the same. -6, 7, 1, 7, 1, 9, -2, 5. Yes? Are you guys following me?
Yep.
Yep.
Now we find the determinant of A1. Is same thing. 7 -2, 1, minus plus 6, 2 -2, 3, 5, and plus 9, 2, 7, 3, 1. Okay, so most of you are here. Okay, good. Most of you are here. So, do I need to solve this, or I can just give the answer?
You just give the answer.
Yeah,
we
because
can look at it later.
I don't want to waste more time. We have to do a lot. So it is. If I do it, it's -38. You know how to solve this. Similarly, I can find A2 matrix. That is, you replace the second column with the
The
with
B term.
with the B term. Yes, yes. Thank you. Somehow this is. Somehow my laptop is out of memory and it's taking more time. So it is. Wait a minute. So it is 3 -2 0 1 2 3 9 -2 5. And so I find determinant of A2, that is, let me do this, 3, 2, -2, 3, 5, -1, -2, -2, 0, 5, plus 9 minus 2, 2, 0, 3. If I do this, I get 4. Please check my answers, okay? And similarly, I can do A3 now. A3 is replacing the third column, so it is 3 minus 2, 0, minus 6, 7, 1, 1, 2, 3. And if I find a determinant of A3, I get 19. So once you have that, we can put that in the equation, in the equation. So my x1 is determinant of a1 by a. Sorry, determinant of a. That would be how much? Minus 38 by 53. You can just give me this. You don't have to. You can give me the fraction. You know.
Was the determinant of A 53 or 33?
Yeah, 33. 33. Thank you. And x2 equals to determinant of a2 by determinant of a, that is 4 by 33, and x3 is determinant of a3 by determinant of a equals to 4 and then 19 by 33. Okay, so this is your answer. So this is your x1, x2, x3.
X.
Sounds good.
Yep.
Second, what's my second? Let me look at the guide. Okay, so find the cross product angle vector, determine the set of span vectors are space R3. So find a cross product. So I have a question for a cross product as well somewhere here. So this one or that one, either, okay? This one or the question I'm going to do now. These are 25 points question. Okay, so so let's say I said 1, right? Let me do this 1, yeah, or this, or let me write or in big way, or okay. So let's say right, this is 2. Let's say for the vectors are shown below, right? You have view vector, like say 3, 3, 3, and you have v vector 1, 0, 4. A, find the cross. CR is a cross. Find the cross product. So you know, it's finding cross product is not that difficult. You can just find. Let me put this in other page. So otherwise, when you print it, okay. So U vector cross V vector is similar to finding determinant. So it will be 3, 3, 3, 0, 4. 3, 3, 0, 4. You take out the you take out the first column or first vector. So 3, 3, 0, 4, and you do minus. Make sure you do the minus, and you take out the second. You take out the second vector. It is 3, 4, 1. Sorry, 3, 3, 1, 4. Are you guys following me? Now you take out for
Yes,
second. You take out you could take out this, and for the third one you take out this. So it is 3, 3, 1, 0. Now it's solve it. So 3 times 3 is 3 times 4 is 12. 0 times 3 is 0. So 12 minus 3 times 4 is 12. 12 minus 3 times 1 is 3, so 12 minus 3 is 9, minus 9. 3 times 0 is 0, 0, 1 times 3 is 3, so it's negative, so negative 3. That's it. This piece of cake. And you need to find out the angle between the vectors. So now B. Is it good, everyone?
Yes, sir.
Okay. So B, find the angle between the vectors. That's what. So when you use cross product, you find sine theta. When you use a dot product, you find cosine theta. So sine of theta is u cross your norm. You're trying to find a norm. Okay, so this is norm of those vectors. Should be scalar. When you find the norm, it should be scalar. You have to remove that. So norm of u times norm of b. So whenever you're trying to find norm or absolute value, right, magnitude, you're trying to find magnitude. So this is you're trying to find magnitude. So it will be 12 square plus 12 square plus negative 9 square plus negative 3 square divided by you want to find magnitude. So 3 square plus 3 square plus 3 square more times 1 square plus 4 square because it's 0, right? So you didn't have to 1 square plus let me make it confused. 1 square plus 0 square plus 4 square. So if you calculate, you should get 15.29, 5.19 times 4.123, and this would give you 0.714. Right now, I can find theta. So what is theta? Your angle is sine of inverse 0.714. That is 45.60. This is your theta. So you found out the cross product, you found out the angle. It's not so difficult. Again, I'm not going to upload this, so make sure you are writing these things. Next, we need to find out if the vector spans in vector space, right? So, do you guys remember what do you do if you find out whether it spans or not? What is the test of spanning? Anyone? Do you guys remember? Do we find the determinant? Do we find the determinant? Yes.
I don't remember.
Okay. So we find the determinant, and if the determinant is not equal to 0, what does that mean? That means it spans. That's it. Okay. So let me say this is 2. Let's say this is 3. Let me write this 3. So for the set of vectors shown below, v1 is 2 minus 3 1, v2 it is 2 is 4 1 1, and v3 it is 0 minus 7 1. So we say determine and explain whether the set of vectors span the vector space R3, because these are three-dimensional. You don't have to explain everything. You can directly solve it. You don't have to find express the component and everything. So if you find the determinant of these vectors, so your your matrix is can someone give me the matrix for this?
The 2, -1, -3, 1, 4, 1, 1, 0, -7, 1.
Yeah. So if let's find the determinant of this. So 2, 1, -7, 1, 1, -4, -3, -7, 1, 1, and plus 0. It's 0. We don't have even do it. So it is if we solve this, 2, 1, 1 plus 8. So it will be 2, 1, minus plus 7, minus 4. Something like that.
Am I crazy, or are you supposed to draw or write the vectors? You wrote them top
Horizontally
to
instead of
top
vertically.
Yeah. So like
No.
the first vector, you did it as the column rather than the first row. I thought you were supposed to do it as the
Yeah,
first row.
it should be 2
yeah,
minus
let me
3, 1.
explain. No, yeah. Wait. It should be like this, but these are vectors. The vectors either you do this, or you vectors are x1, x2, x3, right? That is okay. I'm looking at something else. Let me do this. Let me. So maybe because I skipped the process. Maybe that's why you guys are confused. But
Oh, I see.
what did you find? 4 minus 3, 3. Oh, I skipped the process. That's why I'm trying to see how I can explain it. I don't want to write everything, so that's why I skipped the process. So this is you know what I'm saying. This is like you can express vector like this, right? 2 minus 3, 1, 4, 1, 1.
0, yeah.
0 minus 7, 1, 1. Yes?
Yeah.
Yeah. That's okay. I think I don't need to explain everything because it will be too much. Anyways, so minus 3 plus 7. So it is 2 times 8 minus 4. 4 times 4. So 16 minus 16. Do you guys understand that? Why these are like this?
Yeah.
So it equals to 0. So whenever the determinant is equal to 0, it doesn't span. So your determinant should be not equal to 0 for it to span. So we can write, since your determinant of A is equals to 0, the set of vectors do not span the vector space R3. Okay, it has to be equal. It has to be not. It has to be not equal to 0. So it doesn't span. That is just a spanning. This should be enough. If you see my my practice problem or lectures, it's pretty long. You don't have to do that. Okay, sounds good.
Sounds good.
Yes, sir.
Okay, so next part is next math is eigenvalue, row space, column space. Let me see. So let's do. My laptop says out of memory, which is not good. Okay. So number 4. Number 4. So let's say the matrix A is I'll give you the row. This is we're doing the knowledge space, okay? Knowledge space and the knowledge space, yeah. Row space, row column space, all those things. So let's say A matrix is 3 0 3 3 3 minus 3 1 minus 2 minus 4 minus 1 5 4 9 1 13 7 6 13 1 19. This is our matrix, and our reduce row reduction form is, let's say, B. This should also be given 1 0 1 1 1 0 1 1 minus 1 2 0 0 0 0 0 0 0 0. Okay. So let's first we determine, let's say determine row and column space. Okay, and rank row, column space, row. Let's say row space, column space, and rank. Same like we did in class. So row space, column space, and rank. I think some of you missed this class. So can someone tell me what are the row space over here? What are the row space? Row space are the rows with.
It's the rows with leading ones, right? So it would be row 1 and 2.
Yes, sir. These are the row space. They're the leading ones, right? So row space, your R1 is 1 0 1 1 1, and R2 is 0 1 1 minus 1 2. That's it. So your row space is 2. So your row rank of A is also equals to 2. Row. Okay, since there are 2, the row space is 2. Your row rank is also equals to 2. Okay, you have to be careful when you find the column space. Okay, so this is your row space. When you find column space, we still look at the leading ones, but what do? What extra thing we do? We compare that with the original matrix. So these two column has the leading ones. So we compare with the original matrix. Are you guys following me?
Yes.
Yeah. So your column space vector, or column space is 3 minus 3 5 7, and C2 is 0 1 4 6. Okay, this is your column space. Since there are 2, so your column rank of A is equals to 2. It's little bit it's different than row space. Same process, but it's different. We have to look at the original. So we look at the rank. rank is same as row rank of A, column rank of A equals to 2. This is a rank. Okay, so we found out the column space. It's pretty straightforward. There is no rocket science there. This is crazy, man.
Professor, can you scroll up to show the original matrix?
This is too bad, man.
So aren't there technically ones in, or leading ones in the other 3 columns too?
No,
Oh, right. It's the rows that we're looking at, not the
Yeah. not the column. Yeah,
gotcha. Okay.
it should be 1 and zeros, right? Above and below it should be zeros, right?
Hmm.
Good.
Yes, thank you.
Okay, so now we find the determine the null space and nullity. Okay, so to find null space, we use the row reduction matrix Bx equals to 0. We use this. So this is what 1 0 1 1 1 0 1 1 minus 1 2 0 0 0 0 0 0 0 0 0 0. So we have 5 variables: x1, x2, x3, x4, x5, and our 0 2 3 4 5. This is a little bit tricky. Okay, you have to be very careful when you find the null space. So the corresponding system equation of matrix B will be so 1 times x1, 0 times x2, 1 times x3, 1 times x4, 1 times x5. So it is x1 plus 0 x2. I'm not so 0 times x2 plus 1 time x3 plus 1 time x4 plus 1 time x5 is 0 equals to 0. That's our one of our equations. So I can clean it to x1 plus x3 plus x4 plus x5 equals 0. Can someone tell me what is the pivot variables over here? Which variables? X1, x2, x3, x4, x5. Which ones are leading ones? Which variables have leading ones?
It's 1 and 2, right?
Yeah, x1 and x2. These are called pivot variables. It's very important to know this. To solve this, you need to understand that. Since we have leading ones in x1 and x2, they are the pivot variables. Others are the independent variables. They are the others are the independent variables. Okay, so it's very you need to understand that. So second one is there is no x1 there, so x2 plus x3 minus x4 plus 2x5 equals to 0. Right. So what we do is x1 and x2 has a leading ones, or they are pivot variables. We solve with respect to that because they are dependent. Others are independent. So what we do is solving the equation for pivot variables. We get your x1 equals to minus x3 minus x4 minus x5, and your x2 equals to x2. Oh, this should be, see, I did a mistake over here. This, oh no, yeah, I'm right. x2 equals to minus x3 plus x4 minus 2x5. Did you follow that, everyone? You need to understand this. Otherwise, you won't be able to solve the null space. Everyone good with this? This part?
Yeah.
Okay. So now to find the general solution, right? So for this, we can obtain general solution, that is your x1, x2, x3, x4, x5. So we already have x1 and x2. So since they're independent variables, we have three independent variables: x3, x4, x5. Because we already know the value for x1, x2, x1 and x2. We don't know these values. So x1 is, x3 is -1, x4 is -1, x5 is -1. Yes, if you compare this with this equation. Yep. Do you guys follow that?
Yeah.
Your for x2, x3 is -1, x4 is 1, and x5 is -2. And your independent variable is x3 1, for x3 1 0 0, for x4 1 0 1 0, for x5 0 0 1. Did you get that? Your x3 is 1. We don't know about x4 and x5, and then the independent variable. For x4 we don't know about x3 and x5. We give 1 to x4. Similar with x5. So everyone understood this?
In the column there for x3, the third one, is that -1 or is that just one underlined?
It's one. I just showed it. Yes. Yeah.
Okay, thank you.
Yeah. But confused. Okay. So your null space is span of these matrix: -1, -1, 1 0 0, -1 1 0 1 0, and -1 -2 0 0. This is the span of this one. Is null space. Span. Okay, sounds good. So nullity is nothing but n minus rank of A. What is A? A is number of column minus rank of A. So how many columns we have?
Three.
Sorry? 6?
3.
No, original matrix.
Oh, yeah.
5, right?
Was it 5?
5 minus 3 is nullity is 2. Sorry. No, 5 minus 2. So nullity is 3. Did everyone follow this? This part is a little trickier. This part and this part. If you can do that, then it's okay. So last math part. Can I scroll down?
I'm ready.
One sec.
Yeah, okay. I'll wait. Don't worry. I thought I would finish this in 1 hour.
That's alright, I have nowhere to be.
Yeah, I know. Anyways, I can run through the signal system part because you guys know it. I just want I can just give you guys the question and the answers. I don't have to show all the
Yeah,
process.
for sure. That'd be great.
Yeah, because we have done it so many times. These things, I think so many of you are absent in that class. Kevin was not there, I know.
Yeah, I couldn't make it. I'm sorry.
Yeah, I know. Yeah, some of you are not there. That's why I wanted to do it nicely. Because it's difficult to understand. Okay, guys, I only have 70% evaluation. Make sure I need 80%. Okay, those who have not done it, please do it. I only have 70% course evaluation. Okay, anyways, so last one is number 4. Number 5. Oh my, number 5. That is eigenvalues. So for your matrix, I will ask you only 2 by 2. I'm not going to ask you more than 2 by 2. If you know how to do 2 by 2, you can do 3 by 3. So if your matrix is this is an A matrix, and you need to find eigenvalues and eigenvectors. So determine the eigenvalues. Okay. So there is in the notes I have written the steps. I'm not going to do all the steps, but I mean step by step. If you follow the step by step, it's easier. So maybe in your cheat sheet, make sure you write step by step all those steps. It's easier to follow through. So first we'll find out the characteristic equation. That is A minus lambda I. That's a characteristic equation. You do that, right? So I is your identity matrix. So it is 1, 2, 2, 4 minus lambda 0, 0, lambda, right? Lambda I. So I is 1, 0, 0, 1. So it is 1 minus lambda 2, 2, 4, 2, and 4 minus lambda. So from this we can find like I said, from this we can find out the characteristic equation. So the characteristics equation of A matrix is determinant of A minus lambda I equals to 0. That's what we found. That's what we did there. So we do this to find out the eigenvalues, to find out the value for lambda. So let me put it in another page. So or 1 minus lambda, 4 minus lambda, minus 2 times 2 is 4 equals to 0. 4, 1 times 4 is 4, minus lambda, minus 4 lambda, plus lambda square minus 4 equals to 0. So what is this? 4 and 4 will cancel out, or lambda squared minus 5 lambda minus 5 lambda equals to 0, or lambda lambda minus 5 equals to 0, lambda equals to 0 and 5. This is your eigenvalues. These are your eigenvalues. Somehow it is 4 and 0 and 5. I think you guys understood this one, right? It's okay.
Yep.
Now we need to find out the eigenvectors corresponding to these 2 eigenvalues. Okay, so it says this may be like 10 point, and finding eigenvector may be like 15 point. This is easier. So finding eigenvector is a little bit tedious than this. If I ask you in the exam, So determine the corresponding eigenvectors to the eigen values of part A, or determine. How many of you finished the project?
Turned it in.
Nah, I'm still working on it.
Okay, I think yeah. I don't want to name it, but some of them was able to reduce the 50 hertz, or was able to get rid of 50 hertz. So if you have not, try a little bit. There are ways to do it. Okay, so it is. So we'll first, we have two eigenvalues, so they stay with that equals 0. So what we do is we put that in that equation. That is 1 minus 0, eigenvalue is 0, 2, 4 minus 0. We do is x1, x2, 0, 0. So what we're doing here is this matrix, you know. This is your A minus lambda I x, and this is your B. But we're trying to solve. So, but let's say this is B. So we're trying to solve B x bar equals to 0. And we're trying to find x1 and x2. Are you guys following me?
Yep.
Yeah, because this is your lambda. This is your lambda. Okay. So now I will use row reduction method. It's easier. So 1, 2, 2, 4, 0, 0. So in this way, I can find out. So I have to get 0. So I try to make one row 0, so it's easy to solve. So if I do row 1, 2 row 1 minus 2 times row 1 plus row 2 equals to will give me new row 2. So if I do that, it is 1, 2, 1, 2, 0. It will be 0, 0, 0. Am I right? Yes.
Yeah.
Yep.
So equation would be x1 plus 2x2 equals to 0. So x1 equals to minus 2x2. So like I explained in class, so it can be x1 and x2 can be anything which spans in the same linear line, same line. It can be anything. It depends upon what you assume for x1 or x2. So let's say I assumed x2 equals to -1, then x1 equals to 2. Anyway, it will span in the same line. Or you can assume x2 equals to 1, then your x1 will be equal to -2. You know what I'm saying?
Yeah, that makes sense.
Yeah, this is more important. And depending upon this one, I have to see. Usually, I want to usually assume 1, -1. It will make it easier. So your vectors are what? Your vector is x2. Sorry, not x2. 2, -1. This is a corresponding to lambda equals to 0. This is your vector. Sounds good?
Yeah.
Yeah. Similarly, for lambda equals to 5, 1 minus 5, 2, 2, 4 minus 5, right? x1, x2, 0, 0. So it is -4 to 2 minus 1. Yeah, -1. I want to do the augmented matrix because I want to do row reduction method. So it is if I multiply, if you look at this, if I multiply row 2 by 2 plus row 1 will give me new row 1. I want to make one row 0, so this will give me what? 0, 0, 0, 2 minus 1, 0. Am I right?
I think
But
so.
that'll have
Yeah.
that'll have the same vector, their eigenvector that we had for 0, right?
Must
Mm,
be the opposite, probably.
it opposite it will be like this. The 2, so it will be 2x1 minus x2 equals to 0, right? So 2x1 equals to x2. Am I right? Did you guys get the same thing?
Yeah.
So let's say my x2 equals to 1, or no, let's say my x1 equals to 1, then my x2 equals to 2. So my vector would be 1, 2. If you see here, I always did x1 over here and x2. It's easy. If you follow the same pattern, it's easier. And I always wanted to make x1 positive. If you follow the same pattern, then it's easier. Did everyone follow this, guys?
Yes.
Yes. Okay. Make sure you do the classwork. Classwork, we have done 2 problems. And this is another one, third problem. Make sure you understand that this. If you understand the concept, it's not difficult. Always it's concept. Okay, this is our math part. All right. So, now we have to find. So everyone is comfortable with this?
Yes.
Did this review help?
Yeah.
So now let's do the signaling system. Let me look at my notes. No, not this one. Okay, so I'm not going to solve everything. I'm just going to show you and give the answer. Okay, I think you guys know we have done it so many times. So otherwise, okay. So this is question number 6. So let's say given a LT linear time invariant continuous system, this CRI described by this equation d square y of t by dt. You can use any method, okay? Yeah, either you use time domain or your Laplace domain. It's up to you. Laplace domain is easier than time domain, but it's up to you. Whichever you feel comfortable, you can do that. Plus 4 of y of t dxt by dt. Because if you do Laplace domain, you can directly find out the y of t, so with
Are you gonna give us the same tables that we got from last exam?
yeah. If you have it, you can. Do you guys have it or?
I think I have it somewhere, but it might be kind of.
Okay, I'll bring it. It's okay. I'll just
Okay.
print it and bring it. Yeah.
Cool.
Yeah. With initial conditions y0 minus equals to 2, y dot 0 minus equals to 1. Determine the following for input x of t equals to e minus t u of t u of t. Okay, first we need to find a transfer function. So number A, the system transfer function. How do you find the system transfer function?
Y of t over x of t.
Yeah, it's of s, right? Y of s over YFS over XFS or XFS over YFS?
Oh, why? I just said T instead of S. My bad.
Yeah. So you get is it is x plus 1 x by y, right? Oh, I'm blank. Anyways, so if you do that, you get x plus 1 divided by s squared plus s plus 4. Okay, do that. This is your
Wouldn't it be 4S plus 4?
Yeah, that's 4s.
4s.
Yeah, I got 4s plus 4.
Yeah. You're right. Because there's a 4 over here. 4s plus 4. No, I I missed
Also,
something.
I don't think it would be. Yeah. Okay.
Yeah, I missed something over here. Yeah. X plus 1 by 4s plus 4. Yeah, I missed something. Yep. Thank you. So you know this one, right? So
Yeah.
so when it says find the total response, total response y of t, which is easier to directly find the total response? Which one is easier? Time domain or S domain?
I've always understood S domain better, but I'm not sure which one would be easier.
I mean,
Which
use like an S domain into an inverse Laplace.
S domain is easier, right? Because it will directly find your time. You don't have to find zero input, zero
Right.
state, and then find YT.
Yep.
S domain will directly find YT. So whenever if I ask like total response YT, then just use S domain. It's easier, directly find. And then if you know how to find out total response, from there you can also find out zero state and zero input, right? I did in class how you can find it, right? From YT you can just take out zero state and zero input. So if you use the table, for this one, it is ds square yt by dt. So it would be s square y of s. It's a double derivative minus s y0 minus y dot y0 minus. Okay, and plus it's a first derivative, so it will be only s. There is no s square term. Y0 minus. Okay, plus 4y of s, 4y of s, dy by dt, right? It's 4y of t, so 4y of s. Are you guys following this?
Yeah.
Mhm.
Just directly from the table. Then s, x of s minus x 0 minus, because it's a first derivative, plus x of s. Right? Yes, everyone?
Mm-hmm.
Okay, so then now clean this out. So s square y of s. So what is our initial condition? Y0 minus is 2. So it is s times 2. So it will be 2 of s. Y dot 0 minus initial condition is 1. It will be 1 for s y of s minus 2. That's initial condition, plus 4 y of s equals to x s. This is, I think, this 0. Yeah, it's nothing. It's this plus x of s. The initial condition for it's not given. So now we can clean it out. I can clean it out. I can separate s squared. I can separate ys, and I can separate the s term. So it would be s square y of s minus 2s minus 1 minus 4s y of s minus 8 plus 4y of s equals to x of s plus 1, right? Yeah, this is right. So y of, so I can clean it up. S squared minus 4s plus 4 y of s plus 4 y of s minus 2s minus 9 equals to, this is 1, what is x of s? X of s is e to the power minus t, that is 1 by s plus 1, s plus 1. Am I right?
Mm-hmm.
Laplace. So, or s squared minus 4s plus 4 y of s equals to 2s plus 9 plus 1. This is your zero input, this is your zero output actually. You can when you divide by this, you can find that directly. But anyway, we are not interested in that, so I don't want to confuse you guys. Okay, so y of s equals to 2s plus 9. So this would be s plus 2 square plus 1 by s plus 2 square. So zero input, zero state. S plus 2 square. Okay. Can we solve this? Yes, we can. Right, we can do the Laplace of this, right? And inverse Laplace, and you can find it.
Is it s minus 2?
S minus 2 or s plus 2?
Yeah, it's minus 2.
Oh yeah, it's negative.
Wait. Let me check. I might have done mistake I might have done mistake early. Yeah, this is plus. Did you see that? Yes.
Yes.
Yeah. I slept around one or two yesterday. You know, that's why I need coffee.
Ah, same.
Yeah.
I'm gonna pull up tomorrow with the biggest cup of coffee you've ever seen.
Oh, okay. Oh, tomorrow at 8 a.m., right? Oh man.
Yeah.
I don't like 8 a.m. You know?
No, especially for this, it's so. Oh my gosh.
I don't know why. I think when they schedule it, just boom, just put it there. You know, they don't care what it is. You know,
Yeah.
they just.
Yep, that's what they do.
Just put it there. So if you do that, you get like your y of t is 5t minus 2t plus 2e minus t u of t. Okay, please do this. Okay,
Mm-hmm.
is it okay, guys?
Yeah.
Yeah.
Easy.
Some of you guys who are not good, very rusty at Laplace, inverse Laplace, make sure you practice that. Okay, make sure, please. If you cannot do inverse Laplace, then it's gone. You may lose all the points. You know, so not all the points, maybe half of the points, but make sure you are not rusty in inverse Laplace.
Where did the 5 and the 2 came from? Oh, the initial conditions.
Yeah, initial conditions.
Yeah. Okay. Cool.
Okay, that's it for one of the Sigma system. So next one, the last one is number 7. That is, we are going to do. Oh, I have something. Maybe this one. I prepared this yesterday last night. You know, I was up till 1 or 2. Yeah, to
Jeez.
to select these things. Luckily, I also uploaded some of these as a practice problem, and because and when you have two boys, it's difficult. I have to let me see. I have to find. I have it somewhere. I have to find it. There may be another. Yeah, it's not this one. This one maybe. Yeah, I got it. Yeah, I got it. Yes. The second question I'm going to ask for single line system is frequency response, right? Somehow it's out of memory and everything goes blank, you know. Come on. Give me a second, guys. Give me a second. Okay. Okay. So find the frequency response. Both the magnitude or amplitude, same thing, okay? Amplitude and phase. And for the following system, and a steady state response of the system to the input xt equals to cos 2t. Okay, so it's pretty straightforward. It's very easy. Okay, it's pretty straightforward. So you so system is your h of s is s plus 2 s squared plus 5s plus 4. This is your system. So how do you find the magnitude? You find out the h j omega is j omega plus 2 j omega square plus 5j omega plus 4. Or you can find out the roots from here. The roots will be your -1 and 4 if you find out the roots, right? Then you can directly write this. Instead of writing that, you can directly write j omega plus 1 and j omega plus 4. It's -1 and -4. Okay. So what is omega in this case? Anyone?
2.
2, yeah.
Yeah, 2. So to find magnitude, so J2, sorry, J. Okay, so it is 2 square plus 2 square, 2 square plus 2 square, root over 2 square plus 1, root over 2 square plus 4 square will give us what? A root over 8 divided by a root over 3 times root over 3? No, root over 5 times root over 20. This will give us how much? In the calculator.
Professor, I'd look at the J2.
Sorry, how do you find
J2.
Well, the j gets squared, so it just turns to 1, and then it's
1,
what
yeah.
you square.
square? So -1, but you take the magnitude, you know, absolutely right.
Okay.
Oh, I didn't. Oh, I thought I brought the I brought. Let's see. How much did we get, guys? Root 8. divide by root 5 times root 20. 0.6, 0.59?
Give me a sec. Yeah.
0.5, 0.6, no? So angle is, to find angle of HJ2 is, you need to find out the angle of this one, right? So it would be tan inverse 2 by 2, because omega is 2, right? Or 2 by omega is 2. Tan inverse 2 by 1 is a 1, and then tan inverse, look at the notes, okay? 2 by 4. So this is 45, this is 63.43, and this is 26.56. So it is numerator. This is on the numerator, so it is 45 degree minus denominator. This 1 and 4 in the denominator, so minus 63.43, and
On the first one, is that 2 divided by 2?
yes, sir. It's 2, right? 2, and your omega is 2, right?
Mm-hmm.
Yeah. So omega by the constant term. Okay, minus 26.56 will give us around 45 degree. This is a magnitude and phase, right? This is your phase. This is your magnitude. This is your magnitude.
It does.
Am I right?
Yeah, I remember doing this.
Yeah, we did that. Yeah, we did like 2 of them, I guess. Even in exam, I asked this. So what is your steady state? Y of t. There's an equation for that, right? The magnitude is 0.598 magnitude cosine 2t. The theta is not given. Theta minus whatever is, theta is not given. So minus 45 degree. Minus or plus? I think it's minus, but check that. Let me check.
No, I think it should be minus.
Yeah, I think it's minus. I'll check that. Yeah, minus. Theta minus. Actually it is 2t plus theta minus whatever your angle xj omega. Okay, actually this is the, because in our case, what is theta? Theta is there any theta given over here?
It's 0, right?
Oh, yeah, it's 0. That's why it's like this. Did everyone understood whatever I taught today?
Yeah, quick question.
Yeah.
We did the omega. How do we know omega was 2 again?
Okay, let me scroll up.
Oh, so yeah, so cosine 2. Okay.
Excellent. Thank you. I was going to ask the same thing.
Okay.
Can you scroll down real quick? Minus theta. Okay.
Okay, make your best of luck for your exam. Study well. Okay. Study whatever I gave today. Study in so many different ways. You know, what are different ways you can get the same question. You know what I'm saying? Do the practice problem. Do the class problem. There are different ways you can get the same question. I'm not going to ask the same question, but there are different ways to ask this same question. So make sure you understand that.
Got it.
I took out the state response, and I took out the Fourier series because I want everyone to pass in this class or get good grades in this class. Okay. Again, make sure you do the course evaluation, those who have not already. Okay. See you guys tomorrow at 8.
See you, Professor. Thank
See
you.
ya.
So long,
thank you.
Professor.
Tomorrow.
Thank you.
Bye.